Alright, this next video is on secant lines and tangent lines and some connections that we can make between them, which will also lead us to a conclusion about the definition of the slope of a curve at a point. I'm going to start this discussion off by giving you an alternate way to think about the slope of a secant line. So here we just have a red point at some x value. Functional output is f at x. What I'm going to do in this case, though, is I'm going to add some number h. So now this point over here has an x-coordinate of x plus h and a y-coordinate of f at x plus h. And so if we draw in that secant line, the 2 points that we're going to be using are at x f of x and at x plus h f of x plus h. So the slope then of the secant is equal to f at x plus h minus f at x all over x plus h minus x. And so what happens here is the two x's in the denominator are going to cancel out, leaving us with f of x plus h minus f of x all over h. Alright, that is an expression that should be somewhat familiar to those of you who took pre-calculus. That's often called the difference quotient. Alright, we'll come back to that in just a sec. Here's a specific example of both the secant line and the tangent line now on the same graph. Okay, the green point is going to represent our x, and then this distance here is our h, and so right here then would be our x plus h. Now, what I want you to see here is the green secant line. Notice now if I were to take that h distance and close it. Alright, notice now how the red tangent line, the closer and closer those 2 points get, the secant and the tangent line become the same line. Alright, so again, we started up here, and what's happening is that h value, remember, the h value was the distance here, that h value is getting smaller and smaller. Alright, so that h, as h goes to 0, what happens now is the secant line tends to the tangent line. What we've just seen in that Java sketch that I found on the web, and I'll post the web address of that, is as this h becomes 0, this point moves this direction, the secant line becomes the tangent line. Alright, so we need to describe that with the limit. Alright, so this is how we describe it. Alright, the slope of a tangent line at some point, x f of x, which is this point right here, if we want to find the slope of that green line, we need to look at the expression that we came up with for the slope of the secant line and look at that limit as h goes to 0. Okay, so in the next video I'm going to show you some examples of actually how this works, but I wanted you to be able to see where it came from to more fully understand it.